Hello everyone. Today we are going to learn the concept of heat pump. It is a device which is used to cool the things. For example, refrigerator and AC. We know that water always flow from higher level to the lower level and transfer of heat always takes place from hot body to the cold body. But if we need to transfer the water from low level to higher level, it is required to connect the water pump. Similarly, if we need to transfer the heat energy from low temperature body to the high temperature body, it is required to connect the heat pump. So, heat pump is a device which transfers the heat energy from low temperature body to the high temperature body. It also has three essential parts. First, source. Surrounding acts as source. Sink. The things which we need to cool acts as sink and it is always at lower temperature. Working substance. The refrigerant gases acts as working substance. So when we apply the external work done with the help of electricity, working substance absorbs the heat from the sink at low temperature Q2 and transfer the heat to the source at high temperature, that is Q1. So this is how heat pump transfers the heat energy from low temperature sink to the high temperature source. And if we need to find out how much electricity or work done is applied to transfer the heat, we can simply find out with the concept. Here Q2 and W, they both are going in and Q1 is going out. So we can say that W plus Q2 equal to Q1 and we can write W equal to Q1 minus Q2. It means that कितना heat बाहर transfer किया गया minus कितना heat absorb किया गया. So this is how we can find out the external work done or how much electricity is applied. To understand how refrigerator or air condition acts as heat pump, we need to understand the heat energy versus temperature graph. Now here we have heat energy versus temperature graph. Water in solid state means ice at 0 degrees Celsius absorb the heat energy and get melted. The amount of heat energy it absorbed is said to be the latent heat of melting, and it is the amount of energy which is required to change the state, not to increase the temperature. That's why water in liquid state remains at 0 degrees Celsius. If it further absorbs the heat energy, the temperature increases, and at 100 degrees Celsius it starts boiling and get converted into the form of gaseous state. The amount of heat energy it absorbs to convert liquid to gas state is said to be latent heat of vaporization, and it is a kind of energy which is required to change the state, means liquid state to gaseous state, not to increase the temperature. That's why the gaseous state remains at 100 degrees Celsius. If it further absorbs the heat energy, it gets converted into the form of steam. This whole process has happened at 1 atmospheric pressure. But what happens if we increase the atmospheric pressure? The boiling point increases. And if we again increase the atmospheric pressure, the boiling point increases again and again. Just understand this graph over here. As long as the atmospheric pressure increases, the boiling point increases again and again. And the straight line which shows the latent heat of vaporization, it also decreases. जैसा आप देख पा रहे हैं, at 1 atmospheric pressure, this line is very big as compared to at 200 atmospheric pressure. Means at 200 atmospheric pressure, it require very less amount of latent heat of vaporization, जो कि liquid to gas state में convert कर लेगी as compared to 1 atmospheric pressure. And if we draw the graph of latent heat of vaporization at a different pressure, we will get this kind of curve. And if we reverse this process, means if it convert gas state to the liquid state, that process is said to be condensation process, and amount of heat extracted from the gas is said to be the latent heat of condensation. This whole process is there for water, as we are using refrigerant gases as working substance in our fridge or AC, so they behave same as the water at a different atmospheric pressure. So here we require this curve only to understand how our AC or refrigerator works. The refrigerant in liquid state get entered into the indoor unit of AC or refrigerator. It is also called evaporator. It absorbs the latent heat of vaporization inside the room or inside the fridge and convert the refrigerant in gaseous state. This refrigerant in gaseous state get entered into the compressor and make the pressure high of it. This high pressure gas get entered into the outdoor unit of AC. It is also called condenser. It extracts the latent heat of it and release it to the outer environment and surrounding at high temperature. and convert into the form of liquid state but at high pressure. This high pressure liquid get enter into the expansion valve which make the pressure low of it, and this low pressure liquid refrigerant again get enter into the indoor unit of AC or refrigerator. So this is how the cyclic process continue while cooling inside the fridge or inside the room, and the cyclic process makes possible to extract the heat from low temperature room or inside the fridge and release it to the environment at high temperature. This is how our AC and refrigerator work as heat pump. If we need to find out how much efficient our AC or refrigerator is working, we can use this concept coefficient of performance, and it is equal to how much heat is removed from the sink or inside the room or inside the refrigerator, and it is equal to Q2 divided by how much electricity or external work done is applied, and it is equal to Q1 minus Q2. So we will get the formula Q2 divided by Q1 minus Q2. According to the thermodynamics law, heat energy is directly proportional to temperature. So we can write Q1 directly proportional to T1, and it is the temperature of surrounding, and it is always at high temperature. Whereas Q2 directly proportional to T2, and it is the temperature of sink, and it is always at lower temperature. So we'll get the formula beta equal to T2 divided by T1 minus T2. With this formula, we can improve our efficiency of refrigerator or AC. Just understand with the example over here. For example, अगर सराउंडिंग का टेम्परेचर 33 डिग्री सेल्सियस है एंड इनसाइड रूम का टेम्परेचर 18 डिग्री सेल्सियस सेट किया गया है, देन वी आर गेटिंग बीटा इक्वल टू 1.2. Whereas अगर सराउंडिंग का टेम्परेचर 33 डिग्री सेल्सियस है एंड इनसाइड रूम का टेम्परेचर 26 डिग्री सेल्सियस सेट किया गया है, देन वी आर गेटिंग बीटा इक्वल टू 3.71. Just understand both the example over here. जितना टेम्परेचर डिफरेंस सराउंडिंग एंड इनसाइड रूम का ज्यादा होगा, उतना ही कोएफिशिएंट ऑफ परफॉर्मेंस कम होगा, whereas जितना ही टेम्परेचर डिफरेंस कम होगा उतना ही परफॉर्मेंस अच्छा होगा. So we can say that if the temperature difference between surrounding and inner environment is less, our AC and or refrigerator will be more efficient. Whereas if the temperature difference between surrounding or inside refrigerator or room will be greater, the AC or refrigerator will be less efficient.